Hi everyone, welcome to homework 1.6. As promised, I'm going to start with the classwork. So if you needed help with the classwork or you didn't quite get there, we can go ahead and take a look at that now. If you want to skip to the homework, feel free to fast forward until you get there. There will be a code word somewhere in the middle of the homework, so make sure you're listening carefully. All right, so this says that Noah is buying a pair of jeans. He's using a coupon for 10% off. The total price is $56.70 and there's $2.70 in sales tax. Noah's purchase can be modeled by the following equation. All right, so, hold on just a second. Let me go ahead and put this on Do Not Disturb. Okay, there we go. All right, so, we have this equation right here, and it wants us to talk about each part. So first I'm going to list each term of the equation. So this first one, X, is the missing information, and it says he's buying a pair of jeans and using a coupon, and it gives us the total price, but it never gives us the price of the jeans. So this is the original price of the jeans. And then it says that he has a coupon for 10% off. Well, this minus 0.1x right here is subtracting 10% times x. So this must be the discount of 10%. And then we have 270. We know immediately that's our sales tax that we're adding on to the final price. Sorry, that T just, it didn't turn out good. Let's try this again. Here we go. Sales tax. And then 56.70, it told us, is the total price. So this is just a way to break down the equation that we're given. Now it says, what does the solution to the equation mean in this situation? So the solution, which would be X, is the original cost of the jeans. It says, how can you verify that 70 is not a solution, but 60 is the solution? Well, if we go look at the equation, we have X minus 0.1x plus 270 equals 56.70. And so the way that I could figure this out is by plugging both of those values in. So let's plug in 60 because it tells us that that is the solution. So the answer is to plug it in, or the more appropriate term would be to say to substitute for x. All right, but let's go ahead and do it. So this x right here is really 1x. Right? And remember we talked about if we're taking a discount of something, we're left with the other percent. So if we're taking a 10% discount, we're left with a 90% of the original cost. So 1 minus 0.1 is going to be 0.9x plus 270 equals 56.70. That makes it just a little bit easier. So you can use your calculator, you can do it however you want, but if you do 0.9 times 60, which it says is the solution, you get 54 plus 270 is 56.70. So we can verify that that is the solution. So now it's going to give us some equations that are related to this equation. Each equation is the result of performing one or more moves on that original equation. Each can also be interpreted in terms of Noah's purchase. For each question, determine either what move was made or how the equation can be interpreted, then check if 60 is the solution of the equation. So what you're doing here is looking at what was done. Well, first of all, let's go ahead and I'm going to just reference x minus 0.1x plus 270 equals 56.70. Okay. If we go ahead and look at it that way, we can compare. So here we now have 100 in front of x, a 10 in front of the second x, 270 instead of $2.70, and 56.70 or 5,670. So I can see that what happened here is somebody multiplied the entire thing by 100, right? If we were to take this and multiply the whole thing by 100, this is what we would get as a result. The interpretation can be a couple of things. So some of you said they purchased 100 jeans. Sure, that's possible. A couple other people said when we think about $1, what's in $1 is 100 pennies. So this could be the cost in number of pennies. All right. And then the question is, if I plug in 60, does this work too? So if I do, let's do 100 minus 10x is 90x plus 270 equals 5,670. If you plug in 60 here, does that work? So you need to do the math of that. And again, you can use a calculator if you want. 90 times 60 gives me 5,400 plus 270 does in fact give me 5,670, so that is correct. Do show your work, show how you got that answer, and you can show that it is correct. Okay? Equation B, we have now just x minus 0.1, x equals 54. So one of the things that changed is 5670 has gone down to 54, and it looks like we're missing that tax of $2.70. So what happened here is $2.70 was subtracted from both sides. The interpretation could be this is without tax. We're looking at this equation before tax. And then the same solution, right? So this part I'm going to have you do on your own. Plug it in. If you put 60 minus 0.1 times 60, does that equal 54? All right. Show your work, see if it does. All right, this last one says 0.9x, so we have, instead of, at the beginning we had x minus 0.1x plus 270 equals 5670. We now, instead of these two x terms, have a 0.9x, a 1x term, right? And so what happened here is they subtracted 0.1x from 1x, and so they combined like terms. And the interpretation might be that in this example we're looking at subtracting 10%, but instead of subtracting 10%, we are looking at the 90% left after the discount. Okay? And is it the same solution? Again, plug it in. 0.09 times 60 plus 270 equals 5670. Do you get the same thing? All right, the next part is a puzzle. A puzzle, it's so fun. Okay, so we are going to go ahead and look at this puzzle. And what I'm going to have you do, and you're doing it, I'm going to give you some hints, and then I'm going to have you try to figure it out yourself, okay? If we consider everything in terms of n, m plus m equals n. So that means n equals 2m. That also means if we have two n's added together, that means that p equals 2m plus 2m, right? Because n is 2m. So this is the same as 2m plus 2m, which that means p equals 4m. And then here, if I have an m plus 4m, that means q equals, if we were substitute p with 4m, q equals 5m. And so then if we're asking what is p plus q, well, we know now about it in terms of m, and so we can figure that out. So when you look down at 2 times p, well, we said p is 4m, so 2 times 4m plus m, right? I'm substituting this p with the 4m. I get 8m plus m. And so the question is that the same as p plus q? Well, p we said was 4m, q is 5m, and that equals 9m. So is 8m plus m the same as 9m? Right? So you're going to do the same thing in looking at these next three, right? Use this up here and substitute for your variables with the m variable to see what you get and see if those equations equal 9m, or expressions rather. All right, let's dive into the homework now for real. All right, which equation is equivalent to the equation 6x plus 9 equals 12? So to find out equivalent equations, remember they have the same answers. So we can simply solve for this. So let's go ahead and subtract 9 from both sides. We'll get 6x equals 3. That means x equals 1/2, right? If we divide both sides by 6. Sorry, I skipped a step there. So then your question is, If I go ahead and I plug in 1/2 into the equation, will it be true? Okay, well, if I put 1/2 plus 9, that does not equal 6, so that is not true. If I do 1/2 times 2, that becomes 1. 1 plus 3 does equal 4. That is true. Let's check all of them though. If I do 3 times 1/2, I get 3/2 plus 9 equals 6. Nope, that's going to be too big. We can cross that out. If I do 6 times 1/2, I'll get 3 plus 12 equals 9. That is not true, so that does not work. Okay? The next one says select all the equations that have the same solution. That means you're going to have more than one. So again, let's solve for x. 3x minus 12 equals 24. 3x equals, if we add 12 to both sides, 36. That means x equals 12. So your job now that I've done that part is to see how many of those equations work if x equals 12. You can also manipulate this equation, right? We can say 3x equals 36. I see an equation that already mirrors that, right? We found that out when we moved 12 to the other side. We could divide the whole thing by 3 and see what we get, right? So there's other ways to manipulate that to see if any of these are equal, but one way is to see if, we have the solution to this one. What is it for the other ones? So your job is to find that for this one, and I'm going to give you a hint to say that there are 3 correct answers. So 3. Number 4, Jada has a coin collection with nickels and dimes, and it totals $3.65. It's giving you this equation, right, because a nickel is 5 cents and a dime is 10 cents. And so it says which equation is equivalent to this equation. All right, so we need to look and see what did they do to each one of these. So for letter A, it looks like they multiplied by 100 to get 5. But if you multiply 100 by the entire thing, we would get a much bigger number for this. We would get 10D instead of 1D. And so that one does not work. Letter B looks like it moved over 1 decimal point, so that would be multiplying by 10. All right, and so in this case, though, it became 365. In order to move from 3.65, we would have to multiply by 100. So the whole thing was not multiplied by the same number, so that does not work. The next one says, all right, now we have 5 instead of 0.05. So again, multiplying by 100. And then we have 10. Ooh, that's looking good. And 365. So this one does look like, in fact, they multiplied the whole thing by 100. Oops, that's an N. Okay, so this one checks out. All right, and then the last one says 0.05, so that kept, it says 0.05D. No, we cannot just like switch around the coefficient with the variable, so that is not correct. All right, number 5 says select all the equations that have the same solution as 2x minus 5 equals 15. All right, you now know how to do this because I've modeled this for numbers 1 and numbers 2. So number 5 you can do 100% on your own. You'll be fine. I will give you the hint that there are also 3 correct answers for this one. Number 6 says we have these bananas and we have the price, and we want to know how can we represent this situation in an equation. So we have $4.13 gives us 7 bananas. So if we want to figure out how much each banana is, let's go ahead and divide by 7. So if you have $4.13 divided by 7, that's going to give you 0.59 cents. That means each banana is 59 cents. And so to get how much each cost would be for number of bananas, we're going to multiply 59 times the number of bananas. So our best answer option here is A, because we have an even number. And we can check if we do 4.72 divided by 8 bananas, we also get 59 cents. If we do $5.31 divided by 9, we get 59 cents. All right, 7 says, here's a graph of the equation. Select the coordinate points that represent the solution to the equation. So you want to select all. Again, there's going to be more than one answer. And for this one, you're looking at where the points are. So I'm going to model with the first one. If I'm looking for 2, -3, so over 2, down 3, this point is on the line. So this would be a solution. So your job is to find these points, and see, is it a solution? If it is on the line, it's a solution. If it's not on the line, it's not a solution. Your hint here is there's two more that you're looking for. You can find them. Number 8 says Jada bought some sugar and strawberries to make strawberry jam. Sugar costs $1.80 per pound. Strawberries cost $2.50 per pound. Jada spent a total of $19.40. Which point on the coordinate plane could represent the pounds of sugar and strawberries that Jada used to make jam? So again, in order for it to be a solution, it has to be on the line. The only point that is on the line is B. Keeping in mind that D would mean she spent more than $19.40, C and A would mean she spent less than $19.40. A means actually she didn't buy anything, and so that doesn't fit the solution or the scenario. All right, number 9. Kieran is collecting dimes and quarters in a jar. He has collected $10 so far and has D dimes and Q quarters. The relationship between the numbers of dimes and quarters and the amount of money in dollars is represented by this equation. So remember, a dime is 10 cents, so 0.01. A quarter is 25 cents, so 0.25 of a dollar. And it says select all values D, Q. So this is D, Q that we're looking at. That could be solutions to the equation. All right, so you want to then plug in each of these solutions to see if it works. All right, so if we plug in 0.1 times 100 plus 0.25 times 0, does that equal 10? Well, 0.25 times 0 is going to be 0. So then we're looking at 100 times 0.1. 100 times 0.1 does, in fact, equal 10. So this checks out as a proper answer. Okay? If we're assuming that he collected dimes and quarters in the jar, and it's saying he collected 0 quarters, then, you know, that wouldn't really fit the constraint, but mathematically it does work in the equation, okay? So your job is to test each one of these because it says select all the values, so more than one of those works, all right? So your job is, again, plug those numbers into the equation for D, Q. So that first number is your D that you're plugging in here, and the second number is the Q that you plug in there, and see if it works. If it works, then you got it. All right, your code word for today will be stamp, because we're talking about this guy that collects coins, so let's do a stamp collector. Stamp is your code word for today. Put it at the top of your paper. You have to have actually listened to this video to get the extra credit, okay? All right. It says select all that are equivalent to the original expression. So this is very similar to what you've done earlier. You're just seeing which of these is the same. All right. So for things like this, we're going to go ahead and let's distribute 24x minus 18, right? Distribute the 6 through here. So this one is equivalent. 6 is not equivalent. It's not the same. We can't just do 24x minus 18 equals 6 because we have an x here and an 18 here. Because they are not like terms, we can't combine them. So that's not true. This is also going to be distributive property. So 24x, and then multiply through here, minus 16. So that's not quite the same. All right, and then 12x minus 9. Well, if we have 24x minus 18, and we divide it by 2, we would get 12x minus 9. Or if we multiply 12x minus 9 times 2, we will get 24x minus 18. So this is also a solution, or an equivalent expression rather. All right, so 2, 3, 4, and 5 you can 100% totally do on your own. I will give you the hint that number 2 has 2 correct answers. And 3, 4, and 5, I believe, only have 1 correct answer each. Okay, so that's your hint to help you with this. All right, that is your homework for today. I hope you had a wonderful day. And remember, you can do hard things. Instead of keep, change, flip, we say multiply by the reciprocal. All right, happy homeworking and see you tomorrow.